Recording in progress.
Hello, our project topic is image inpainting. This is computer vision technique of restoring the damaged part of the image by using the remaining part. This technique is widely used in restoration of old pictures, of removing unnecessary part of the picture. For example, it might be a tourist on the vacation photo. So our goal is to reconstruct the damaged part of the image by using SVD-based approach of approximation of target region.
Okay, so in the beginning of our algorithm, we have target region with damaged part of the image and source region with good part. First thing we do is calculate approximation matrix using harmonic inpainting and SVD approximation. Then, with inpainting function, we fill our target region with patches from source region. In the end, we apply multiscaling to calculate our target region in smaller image, fill it into the bigger image, and use inpainting to make it look smoother and better, and do it several times. So how SVD approximation works? First of all, we fill our matrix with some numbers. It's harmonic inpainting. These numbers may be good, maybe not. Then we use SVD approximation to get rid of unnecessary noise on our image. How SVD approximation works? We have singular values which represent different pattern of our image. The bigger the value, the most valuable pattern it is. So we're trying to get rid of smaller singular values and see if we can get rid of this noise. But we can't go too far because we can damage our good image. So we calculate this SSIM value to compare our matrix with initial one and know when we should stop. In the end, we have approximation matrix of our image.
So as Petro mentioned, basically we have an approximation matrix and our initial color matrix. Firstly, let's take approximation matrix and split its source region. It is everything except for the target region. So split its source region in small pieces called patches. Then we split target region in patches and take patches from target region one by one. Each patch we compare with all patches from source region to find the most similar one. When we found the most similar patch from the source region, we move to the color image and propagate pixels from the patch that has the same coordinates as the most similar patch from source region in the approximation matrix. So values of pixels in this patch in color matrix to the corresponding patch in the target region in color matrix. We repeat such procedure for each patch from the target region and obtain an inpainted image. Also, in our algorithm we use multiscaling, but it is like additional feature. Basically, multiscaling is downsampling the picture, in other words, making it smaller. So we make our image firstly 1/2 times smaller, two times smaller, and then 4 times smaller, and we can represent it as such pyramid as on the left side. Why did we do so? It is to propagate more information to the base image before the inpainting it. So firstly, we inpaint the most high image, the smallest one. We inpaint it, then take the target region from this, the smallest image, enlarge it, and propagate values of enlarged target region in the target region of the second level. Then with these values, we repeat the procedure of inpainting for the second level and propagate values from this level on the base. And in the end, as a result, in the base, we have more information about target region, and it helps us to find better patches for the target region of original image.
Here are some processed image. As you can see, here we have a target region which was reconstructed with our algorithm. As you can see, it sketches the main pattern very well, but there is still some noises, as you can see on the next picture. On the other picture, you can see that our algorithm works the best where there is a lot of repeating parts and if the image is symmetric. But there is some problem. We can't use our algorithm for pictures with thin lines as it's hard to make a good approximation of it. But it's good working on the picture of waves, as we have a lot of repeating parts, which is very similar.
During implementation of our algorithm, we encountered some troubles. The first one was the butterfly image, and you can see in this image on the left side after biharmonic painting. Even after biharmonic painting, there is still a great white part in the target region. And since this part is really great, SVG considers it not as a noise, but as a general pattern of the picture, and we can't apply it to have the resulting image, to have a good resulting image. So we didn't know what is the trouble, and we investigated this problem. After some experiments, after some investigation, we found out that the problem is that the mask of target region is shifted from the target region itself during the scaling procedure. As you can see on the, we can see it on the second image of the butterfly, where the black square is a target mask. Then we made some improvements to our algorithm. We enlarged target region and shifted, and now we have really beautiful result of biharmony in painting. The second trouble was with an image of birds that you can see under the butterfly. You can see that there is really inappropriate part in this image, and it is the part where the bird was. But why it isn't? But why isn't it substituted with appropriate parts? For example, on the approximation matrix, we don't have any bird here. And we don't have elements with inappropriate features too. So what's happened? Let's look on the inpainted image of level 2 of our pyramid. We can see that even on the level 2, there is already patches with a different color from what it should be. So we thought about this problem and understood, all in all, that the trouble is that we don't take into account the color of pixels surrounding our target region. Therefore, colors are a bit inappropriate, but when we propagate this information on the base level, it becomes completely inappropriate with what it should be. Unfortunately, we didn't fix this trouble yet, but we plan to do it in the nearby future. Now let's look at how our implementation actually works. We will test it on the test image with the damage region, its image of the cover. Start. Actually, the process of calculating is quite long. So I propose you to look at the intermediate stages. First we have the harmonic painting, then we move to the approximation matrix, which is quite well already. Then we progress filling it with the patches, progress, and obtaining pages level 2. Its information propagate on the level 1 and have one more approximation of level 1 already. Then we fill it too, and not to wait a long time, let's look at the result that we obtain. It's the result of work of our algorithm. I think it's quite well. I think that we made some progress in implementing the SVG-based algorithm. Thanks.
Recording stopped.